When you're building data pipelines at scale with Maia, you have two powerful ways to work. If you want to move fast, Matillion's MCP server is perfect. It handles the back-end heavy lifting automatically, so you can build intuitively and at speed. But if your workflow demands deep customization, Maia's Agent Tasks API gives you complete, programmatic, fine-grained control over your AI agents. In this tutorial, we're going to look at both approaches. First, we'll see how to spin up pipelines effortlessly using the MCP server. Then we'll dive into the Agent Tasks API, exploring the endpoints that let you orchestrate complex data engineering tasks exactly the way you want them. Specifically, in both examples, we'll build a customer analytics pipeline, joining the orders and customers table, aggregating the results by customer, and writing the output to a customer order summary table. First of all, let's start with the Matillion MCP server example. To work with the Matillion MCP server, you will need to follow the setup instructions found on this documentation page, which will be linked in the description of this video. Once set up, you will be able to interact with Maia via your AI client, and in this example, I will be using Claude. You can see me interacting with Maia via a Claude agent connected to the Matillion MCP server. I am making my requests using natural language, and when I check the result in the project window of Maia, I can see that I am creating pipelines just by interacting with Claude using natural language. However, what if we wanted to interact with Maia directly using the Maia API? Well, in the following example, we are going to achieve the same result, but doing so programmatically using scripts and the various Maia API endpoints. Along the way, we'll cover creating and monitoring tasks, handling Maia's decision points, reading its messages to verify what it built, and sending a follow-up to refine the pipeline once it's running. We will use Python to run our scripts in this tutorial, but this doesn't mean you can't use any other programming language. As we will be using Python in this tutorial, we need to make sure we have access to the requests library. Other prerequisites to be aware of, if you are following along, include a Matillion API key, which you can generate from your account settings. We will walk you through how to do this later in this tutorial. As well as a Matillion API key, a Matillion project will be required along with your project ID and environment ID. We will also guide you on how to find these as we go through the course, if you don't have them to hand already. For this tutorial, we will use the Maia Agents API to create a customer analytics pipeline. First, we will need to create a file named Step 0 Agent Tasks Tutorial Base. You can copy the template provided, and we will replace the placeholder values. This script will just contain our setup information and variables. It also contains an OAuth token request that exchanges your client ID and secret for a token. Tokens have an expiry time, so for this tutorial, we will grab a new one for each script we create. So in this first script, we need to insert our client ID, client secret, project ID, environment name, source branch, and target branch. We will need to replace each placeholder with our own values for this script to work. To create a client secret and ID, you will need to log in to Maia. Then click your profile and account icon in the left navigation. Select API credentials from the menu, click Add an API credential, give it a name, select a role, and click Add. The UI will now reveal the secret on screen. Copy it immediately, as you will not be able to view it again after this. Now would be a good time to replace the placeholder for this in our script. The client ID can also be found here in the API credentials window. Let's copy that into our script now as well. To find our project ID, The easiest way is to look at the URL when we have a project open. It appears after project /. I'm also going to copy this to the placeholder now. The environment name can be found in a few places in the UI. For example, when working on a branch, it is always at the top left. It can also be found in the default environment column of the branch tab, once you have opened your project. I can copy this from here into the script. This Agent Tasks tutorial-based Python file will serve as the base for each subsequent script to accomplish each task. So we will save this file and use a copy for each subsequent task. So let's save a copy of the base file as step1_create_task.py. Now we're going to copy the first script to the end of this file. If you are following along, you can copy the script in the Copy These Scripts folder called Copy for Step 1 Create Task. Let's look at the script now. For this task, we have created a script that interacts with the Agent API, specifically the Tasks API endpoint, and it instructs Maia to build the pipeline that will join the orders and customers tables together, aggregate the results by customer, and write them to a table called customer_order_summary. The actions of this script will be very similar to typing a message in a Maia chat window for the first time. When using the API, we define the prompt and start our chat thread with the Maia agent in a single API call. So let's save this file and run it. After running the script, we can see in the terminal that we created the task and received the task ID. We should save this ID, so for now I'm going to copy it to my notes. For the next script, we are going to make another copy of the first base template and save it as step2_list_tasks.py. Like the last script, we will copy the template that has been saved in the Copy These Scripts folder called Copy for Step 2. In this script, we want to verify that our customer orders summary task has been accepted and is definitely running. This function retrieves all tasks for our project. It filters by the project ID that we set in the first configuration part of the base script. It's worth noting that this script also uses the same Tasks API endpoint we used in the previous script that created the task. It's just using a get method instead of a post. So let's run it. In this case, we can see our total tasks and the task we just created has already stopped running, which suggests the request to the Maia agent was simple and quick to implement. Let's ask Maia to create a more complex task. I'll make another copy of the base script and name it step2b_create_complex_task.py. Just like the last two times, we will copy the code in the Copy These Scripts folder called Copy for Step 2b. In this script, we can see that this task asks Maia to build a multi-stage pipeline, read both tables, add a calculated column, join them, aggregate them, and write the output. Make sure you rename the target branch to a relevant name. In my case, I will call it Maia API course /complex task. I'll run this script and we can see the task is running now. It's given me a task ID which I'm going to make a note of. We will now check the status of this more complex task. In a new copy of the base script, I'm going to delete project ID, environment name, source branch and target branch. The only variables needed for this script are client ID, client secret, and the derived base URL, access token, and headers. I'll copy the code in the Copy These Scripts folder called Copy for Step 3. It's worth noting that this script uses the task ID endpoint. In this script, you can see I have two functions. Check status makes a single GET request to the API, asking what's the current status of a task, and prints it. Wait for completion calls check status in a loop every 10 seconds, exiting when the task is finished, errored, or waiting for decisions. I'm going to paste the task ID from the complex task we just created into this script. To do this, I'm going to create the task ID variable and paste in the task ID. I'm going to save the script and then I'm going to run it. We can see that in this case the task status is running, but Maia is waiting for us to make a decision. We need to approve those decisions so Maia can continue building our pipeline. So let's save a copy of the base file as step4_handle_decisions.py. Similarly to the previous script, we won't need project ID, environment name, source branch, and target branch, so we can delete those. Once again, I'll copy the code in the Copy These Scripts folder called Copy for Step 4. As you can see, to handle decisions, we will use the decisions endpoint in this script. It's also worth noting that you need to remember to add the task ID of the complex task we just ran. In this script, we can see it reads the pending decisions from the task object and auto-approves them. In a production script, we might want to review each decision before approving it, but for this tutorial, I'm going to auto-approve. After running this script, we can see that the decisions were auto-approved and the task resumed. Now if we run script 4 again, we can see no more tasks are waiting for decisions. So now that we have finished building the pipeline, we should read Maia's messages to confirm that it created what we asked for. Reading messages is the primary way to see what Maia actually did. We can follow its reasoning, see which files it created, and verify the pipeline is correct before we move on. So let's save a copy of the base file as step5_read_messages.py. As usual, we only need the client ID, client secret, and task ID. Next, I'll copy the code in the Copy These Scripts folder called Copy for Step 5. This script will make use of the messages endpoint. This read messages function fetches the message history so we can see exactly what Maia did, which files it created, what components it added, and whether it encountered any issues. I added some extra logic to the script to ensure it printed all the messages in an easy to read format. After running this script, we can see the full message history in our terminal, including Maia's reasoning about how it structured the pipeline, which components it added, and confirmation that it committed and pushed the changes. Now that we have confirmed that Maia has completed the pipeline, let's log in and see it in the user interface. Here you can see I've sampled the last component in the pipeline that Maia built for us. After reviewing, we realise we should exclude low-value order totals under $10. Instead of starting a new task from scratch, we will send a follow-up to the same task. One of the most powerful features of the API is that we can iterate on our pipeline without losing context. So let's save a copy of the base file as step6_send_followup.py. As usual, we only need the client ID, client secret, and task ID now, so let's delete the other variables. Underneath, I'll copy the code in the Copy These Scripts folder called Copy for Step 6. The functions inside it send a new instruction to the same task. If we wanted to change the follow-up, for example, filter by date instead of amount, we'd edit the message string. After running this script, we'll see Maia resume, and we will receive waiting messages while we wait for Maia to finish. Once Maia is finished, we will see the task stop, and we will get the task messages from Maia. The messages at the end confirm where the filter was placed and what condition it uses. If we go back to the user interface, we can confirm that Maia added the new filter component. In this tutorial, we used the Maia Agent Tasks API to programmatically build, monitor, and iterate on a data pipeline using Python scripts. By automating interactions with Maia AI agents, we demonstrated how to move from manual pipeline creation to code-driven engineering. By integrating Maia directly into your scripts or CI/CD workflows, you can automate repetitive development and scale your data operations with minimal manual overhead. If you want to learn more about the API, head over to our docs for a full list of available endpoints. To learn more about Maia and its capabilities, head to maia.ai.